Am I audible, students? Am I audible, students? Can you listen to me properly? Am I audible? So where are other students? Okay, students. Before moving to the assignment part, before discussing assignments or questions of assignments, I would like to discuss one topic with all of you. And that topic is improper integral. Improper integral. So first of all, we will see improper integral, and then we will continue with second assignment, assignment number 2, eigenvalue, eigenvector, and all. Okay. So first of all, we will see improper integral. सबसे पहले improper integral देखेंगे, उसके बाद हम assignment 2 eigenvalue, eigenvector का डिस्कशन करेंगे. ये हमारे आज के लैब का प्लानिंग हुआ. चलो, so first of all, who will let us know that what is improper integral? कौन बताएगा improper integral क्या होता है? What is improper integral? Can anyone try to answer that? This is integral. This is integral. Okay. Integral. Then which kind of integral is said to be improper? Which kind of integral is called improper? At least try to answer. Okay. Okay. Suppose we have just a minute, students. Just a minute. Can everyone see PowerPoint presentation? Can everyone see PowerPoint presentation? Okay, thank you, Vishwajit. So suppose we have integral from a to infinite fx dx. Okay, so here upper limit is not defined. Upper limit is not defined. Suppose we have minus infinite to up to b fx dx. So here lower limit is not defined. Here lower limit is not defined. Suppose we have minus infinite to infinite fx dx. So here both limits are not defined. Both limits are not defined. Okay. So this is type 1 improper integral. So these all are improper integrals. Integrals are not proper due to infinite, minus infinite, and minus and plus infinite. And that is why these integrals are improper. That is why these integrals are improper. Improper because of this infinite limits. Okay. And it is called type 1. Type 1 improper integral. So these are some integrals, let us say improper integrals. Now if I write 0 to 1, 1 upon x dx. 0 to 1, 1 upon x dx. So how to integrate it? How can we integrate it? Yes, please. How can we integrate such integral? Okay, log mod x, Viswajit. Okay. First of all, students, when we put x is 0, so when x tends to infinite, but log 0 is not defined. Yes, Viswajit, perfect, perfect. So when in this 1 upon x in fx, if we put x is equals to 0, x tends to 0, then given function 1 upon x tends to infinite. Then fx tends to infinite. So this is not proper. This is improper integral because at lower limit, at 0, at x is equals to 0, 1 upon x is not defined. At 1 upon, sorry, at x is equals to 0, 1 upon x is not defined. Similarly, if I consider 0 to 1, 1 upon x minus 1 dx. So if we put x is equals to 1, so when x tends to 1, then fx 1 upon x tends to infinite. So at x is equals to 1, 1 upon x minus 1 is undefined. It is not defined. Okay. And similarly, if I consider minus 1 to 1, 1 upon x dx. So when x tends to 0, putting 0, then 1 upon x function tends to infinite. Function tends to infinite. So at x is equals to 0, 1 upon x is not defined. So what does it mean by at lower limit function is not defined, at upper limit function is not defined, and between minus 1 and 1, within both limits, between minus 1 and 1, function is not defined. So this is type 2. This is type 2 improper integral. It is type 2 improper integral. Okay. So we have two types of integrals which are not proper. हमारे पास दो ऐसे integrals हैं जनरल फॉर्म में, जो इम्प्रॉपर है. ओके, सो प्लीज राइट डाउन improper integral. Improper इंटीग्रल एंड उसमें लिखो टाइप 1 improper integral. Type 1 improper integral. Okay, so please write down. The integral a to b fx dx is said to be improper integral of type 1 improper integral of type 1 if either lower limit or upper limit or both limits are infinite. So we can say a to infinite fx dx upper limit, minus infinite to infinite minus infinite to b, let us say fx dx lower limit, and both limits. Okay, so this is the type 1 improper integral. So please note down type 1 improper integral. लिख लीजिए. Okay, now let us see some examples of a type 1 improper integral, and let us see how to solve it. Okay, so question number 1, that evaluate 0. Okay, before that, let me give a general form. So if we have a to infinite fx dx, then simply write down a to up to m, where limit m tends to infinite. Okay, m is such a number which tends to infinite. M gets closer and closer to infinite. It will never ever becomes infinite. Okay, M infinite को approach करेगा, वो कभी infinite नहीं बनेगा. So limit m tends to infinite, a to m fx dx. Similarly, if we have minus infinite to b fx dx, then we have minus m to b, where limit m tends to infinite fx dx. Same concept. And if we have minus infinite to plus infinite fx dx, then limit m tends to infinite minus m to plus m fx dx. So if you can observe, this integral is now proper, because this is finite, lower limit finite, upper limit finite. This integral is proper because lower and upper limit are finite. This integral is proper because lower and upper limits are finite. So these all integrals, right side integrals, are finite, proper. Okay, in which m tends to infinite for each. M tends to infinite. So this is the way we can convert improper integral into proper integral. Improper integral into proper integral. Please note down so that we can see some questions. Please note down. Okay, let us see some questions. First question. That evaluate 0 to infinite 1 upon x square plus 1 dx. So evaluate and check the convergence of the integral and check the convergence of the integral. No, Janil. This is not from second assignment. No. Again, students, this is a new topic. This is a new topic. Improper integral. Okay, this is a new topic. Today we will discuss type 1. Today we will discuss type 1 improper integral. We will see questions of type 1 improper integral. After completion of type 1, we will see assignment number 2. We will see assignment number 2. So there will be separate assignment of improper integral. Improper integral का separate assignment होगा. ये टॉपिक है, नया टॉपिक है. आज की लैब में हम टाइप 1 इम्प्रॉपर इंटीग्रल डिस्कस करेंगे. उसके बाद असाइनमेंट 2 डिस्कस करेंगे, क्योंकि असाइनमेंट 2 में बहुत सारे टॉपिक हो चुके हैं. दर्शना मैम ने असाइनमेंट 2 के कुछ टॉपिक्स प्रैक्टिस में करवा दिए. So this is not from आइगन वैल्यू आइगन वेक्टर. ये मैट्रिक्स एल्जिब्रा 2 का टॉपिक नहीं है. This is a new topic. You can say new chapter. Let us say new topic. ये छोटा सा टॉपिक है. So this is a new topic. Okay? Am I clear to all of you? Am I clear to all of you? Okay, Vishwajit. Chanel, are you clear? Okay. So again, students, please anyone let me know that what Divya ma'am is right now discussing. What is going on within lecture session? कोई मुझे बता दो. Vishwajit, Janil, anyone please let me know what is. Okay, orthogonality, similar matrices. Okay, so okay, your matrix algebra 1 is done. One chapter or one of the unit is done. Second unit is matrix algebra 2. So it is going on. Okay, it is right now going on in lecture section. In lecture session, it is going on. And right now we are discussing. Right now we are discussing a new topic, that is improper integral. It is another unit. Now is it clear to all of you? It is a new chapter. Please, students, let me know now. Is it clear to all of you? Okay. So again, in improper integral, we have type 1, type 2, and so on. So within this lab, we will see type 1. Okay. In next lab, we will see type 2. So this is type 1 improper integral. The way we can convert improper to proper. And now let us see questions. So this is question number 1. So what is convergence of the integral? That we will see at the end of the solution. First of all, we have 0 to infinite 1 upon x square plus 1 dx. So it is a limit m tends to infinite 0 to m 1 upon x square plus 1 dx. This is improper. This is proper. Improper to proper. Okay. So limit m tends to infinite. Integration is 10 inverse x upon 1, 10 inverse x from 0 to m. Limit m tends to infinite. This is a 10 inverse m minus 10 inverse 0. Now putting m is equals to infinite, such that we have 10 inverse infinite minus 10 inverse 0. 10 inverse infinite is equals to pi by 2. This is pi by 2. And 10 inverse 0 is 0. So we have pi by 2. So this is a finite unique number. Finite unique. So integral is convergent. Integral is convergent. Sequence and series, your previous semester topic, sequence and series. So if it is a finite unique convergent, either plus or minus infinite, answer is if plus infinite or minus infinite, then it is a divergent. That we will see in each question. But except this one, is there any doubt? Except last statement, is there any doubt? Okay. Let us see a few more questions so that you'll get more idea. That check the convergence and evaluate one to infinite 1 upon x dx. We have 1 to infinite 1 upon x dx. So this is the limit m tends to infinite. Infinite becomes m. So 1 to m 1 upon x dx. Limit m tends to infinite. This is log mod x from 1 to m. M tends to infinite. We have log m minus log 1. Putting m infinite, so it is log infinite minus log 1. Log 1 is 0 and log infinite is infinite. And such that given integral is divergent. Given integral is divergent. Please note down. Okay, let us see the next one. Check the convergence and evaluate one to infinite 1 upon x square dx. Okay, I have made a small change. Here we have 1 upon x. Now I have taken x square. Yes, I'll share this PPT, no worry. You will get the material of improper, no worry. आप शांति से समझ लो पहले, मटेरियल तो ठीक है, वो मिल जाएगा आपको. हाँ, समझ लीजिए शांति से. Okay, so we have 1 to up to infinite, 1 upon x square dx, limit m tends to infinite, one to m, 1 upon x square dx. So m tends to infinite, 1 to m, x raised to minus 2 dx. M tends to infinite. So this is x raised to minus 2 plus 1, minus 2 plus 1 from 1 to m. M tends to infinite, 1 upon minus 1, x raised to minus 1, 1 to up to m, limit m tends to infinite, 1 upon minus 1, this is 1 upon x from 1 to m tends to minus 1, this is minus 1, 1 upon m minus 1 upon 1. And now in place of m putting infinite, minus 1 same, 1 upon infinite minus 1. 1 upon infinite is 0 and minus minus plus 1. So this is a finite, unique, and therefore given integral is convergent. Given integral is convergent. Please note down and let me know if you have any question. So this is question number 1. Question number 2. Question number 3. Let us see fourth one. check the conversions. And evaluate 1 to infinite 1 upon x cube dx. Okay, there is a reason to consider such numbers. Okay, x to the power 1, x to the power 2, x to the power 3. So there is a reason. So we have 1 to infinite 1 upon x cube dx is limit m tends to infinite 1 to m 1 upon x cube dx is limit m tends to infinite 1 to m x raised to minus 3 dx is equals to limit m tends to infinite x raised to minus 3 plus 1 minus 3 plus 1 1 to m tends to infinite 1 upon minus 2 x raised to minus 2 is 1 upon x square 1 to up to m is minus 1 upon 2 1 upon m square 1 upon 1 square m tends to infinite minus 1 upon 2. Okay, let us put infinite in place of m. Let us put limits. So I'll get 1 upon infinite square. 1 upon 1 square is 1. So minus 1 by 2. This is 1 upon infinite. This is 1. So we have 0 minus 1. 1 by 2. So it is a finite unique. And therefore integral is convergent. Ask if you have any question and please note down. Okay, students. Now again, see, here power of x is 1. Here power of x is 1. And answer is divergent. Power of x is 2. We have 1, convergent. Power of x is 3, 1 by 2, which gives convergent. So we have one conclusion that 1 to infinite 1 upon x, 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 1 to infinite 1 upon x. If power is 2, 3, power is 4. So if power is more than 1, integral is convergent. If power is 1, if power is less than 1, suppose we have 1 by 2. If power is less than 1, then it is divergent. Then it is divergent. And this is nothing but zeroth test, if you remember. I'm sorry, it is not zeroth, it is P test. I'm sorry. It is P test, if you remember. Or P series, sequence and series. So this is the derivation for P series. What we have discussed is the derivation of P series. Please note down as fast as possible. Okay, let us see a few more questions. I think it is question number 5. Check the convergence and evaluate five to infinite, 5x divided by 1 plus x square raised to 3 dx. So first of all, five to infinite, 5x divided by 1 plus x square raised to 3 dx is limit m tends to infinite, 5 to m, 5x over 1 plus x square raised to 3 dx. So limit m tends to infinite. And let us write down 5 outside. We have 5 to infinite, 1 plus x square raised to minus 3 into x dx. So this is what we have. We will try to answer that how to integrate, and it is m, not infinite, it is m. How to integrate this term? Okay, so multiply and divide it by 2. Multiply and divide by 2. Reason is very simple. If you differentiate this term, you will get 2x. Differentiation of this term is 2x. Okay. So we have limit m tends to infinite, 5 by 2. 1 plus x square raised to minus 3 plus 1 divided by minus 3 plus 1. So this is the integration between 5 to m. If you remember, integration fx raised to m f dash x dx is fx raised to m plus 1 divided by m plus 1. Okay, we used this formula. Okay, please note down so that I can write in the next slide. Please note it down. Okay, so we have limit m tends to infinite, 5 by 2. Then minus 3 plus 1 is minus 2. So it is 1 upon minus 2. Then 1 plus x square raised to minus 2. 1 plus x square raised to minus 2 from 1 to m. So m tends to infinite, 5 upon 4, which is a negative. This is 1 upon 1 plus x square power 2 from 1 to m. So minus 5 by 4, putting m. Okay. First of all, putting m and then infinite. So it is 1 plus infinite square minus 1 upon 1 plus 1 square. Okay. So minus 5 by 4. This is 1 upon infinite square. 1 plus 1 is 2 square. So we have minus 5 by 4. 1 upon infinite square is 0. Minus 1 by 4. So this is 5 by 16, which is a finite unit. And therefore, integral is convergent. Okay, please write down, please note it down. Okay. Next question. Question number 6. Check the convergence and evaluate 0 to infinite e raised to minus 5x dx. Okay, so you will try to solve it. You all will do it. आप लोग try कीजिए, solve कीजिए. चलिए. Okay, we have one solution, one answer, and it is correct. Let us wait for other students. Is any other student is done? Okay, see that we have 0 to infinite. Is limit m tends to infinite, 0 to m. So limit m tends to infinite, e raised to minus 5x divided by minus 5 from 0 to m. So we have minus 1 upon 5, 1 upon e raised to 5x, 0 to m. limit m tends to infinite minus 1 upon 5. 1 upon e raised to 5m, 1 upon e raised to 0. So we have 1 upon e raised to infinite, e raised to 0 is 1. One upon e raised to infinite is infinite. 1 upon infinite is 0. And 1 upon 5, which is finite. So it is convergent. Please note down. Okay, next one. 0 to infinite dx 1 plus x square 1 plus 10 inverse x. Again, try to do it and then we will see, we will verify the answer. आप कोशिश कीजिए, उसके बाद हम वेरीफाई करेंगे. Okay, Vishwajit, 1 plus pi by 2 log function. Very good, Vishwajit. Very, very, very good. It is absolutely correct answer. What about other students? Okay, today
Sir, we are
let
trying.
me. Yes, Raj.
Sir, we are trying.
Okay, carry on, carry on. And today let me talk to all students one by one. So that I came to know that students are attending the lab session or not. Yagnik, Yagnik, I simply will call you twice or maximum 3 times. Thrice. Why your audio is not available, Yagnik? So where did you leave off? कहाँ तक आपने solve किया? शुभम, शुभम, बात करो. शुभम, talk to me.
Yes, sir.
हाँ, कहाँ तक solve किया आपने?
सर प्रोसेस कर रहा हूँ सर.
हाँ, कहाँ तक? Step बोलो.
ये 10 इनवर्स का जो है ना वो हो रहा है.
Okay, रौनक. रौनक, बात करो. रौनक, कहाँ तक solve किया? Yes, रौनक. Yes, रौनक. No, no, रौनक. Okay, नंदन. नंदन, बात करो. Everyone has to talk to me. Do not write anything in a chat box. Chat box में मत लिखो, बात करो. Yes, नंदन. Meet, meet Kanani. Talk to me. Malhar, no Janil, Malhar, Malhar, Harsh, Harsh, बात करो, talk to me. Devang, Deep, Deep, Vekaria Deep. Okay, 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 students. See the solution. First of all, we have 0 to infinite dx. Okay, so limit m tends to infinite, 0 to m dx, 1 plus m square, sorry, 1 plus x square, 1 plus 10 inverse x. Okay, so we have m tends to infinite. Assuming 10 inverse x is equals to t. So 1 upon 1 plus x square dx is dt. Okay, limit is 0 to m. So if we put 0, x 0, then t tends to 0, 10 inverse 0 is 0. And if x is m, then t is 10 inverse m. Okay, so we have 0, this limit, 0 to 10 inverse m. This term, this one, is equals to dt only. and we have 1 upon 1 plus tan inverse is t. So integration is log function, log 1 plus t from 0 to tan inverse m, where m tends to infinite. Now putting both limits, so we have limit m tends to infinite, log 1 plus tan inverse m minus log 1 plus 0. Okay. In place of m, putting infinite gives log 1 plus tan inverse infinite, and this is log 1 only. So this is log 1 plus tan inverse infinite is pi by 2. Log 1 is 0. So Vishwajit, your answer is correct. Very good. It is log 1 plus pi by 2. Channel C, where did you make any mistake? Verify it and simplify. Please note down. Okay. Minus infinite to minus 2. 2 divided by x square minus 1 dx. So this is the next question. Then similarly, we have minus infinite to plus infinite, x raised to 3 divided by x raised to 4 plus 1 raised to 2 dx. Okay, its answer will be 0. Its answer is log 3. So these two questions are in homework. Okay, please note down, both questions are in homework. So again, students, this is a new chapter, new topic. ये नया चैप्टर है, नया टॉपिक है, improper integral. This is type 1 improper integral, type 1. Okay. During the lecture session, please inform Divya madam that type 1 improper integral is done. Type 1 improper integral is done. Okay. So this is the general form of type 1 improper integral. Improper to proper, improper to proper. And these are the questions. These are the questions. Eight and 9 are in homework. So in a next lab session, we will see type 2. Type 2 improper integral. Now let me share assignments. Let me share assignment number 2, which you will complete within this week. Which you will complete within this week. Okay. So here it is. Assignment number 2. So question number 1, which I think Darshna ma'am has discussed. ये पहला क्वेश्चन जो दर्शना मैडम ने डिस्कस किया था. आइगन वैल्यू, आइगन वेक्टर, जियोमेट्रिक एल्जेब्रिक मल्टीप्लिसिटी. इज इट क्लियर टू ऑल ऑफ यू? आप मुझसे बात करते जाओ ताकि मुझे पता चले. ये आपको मंडे तक सबमिट करना है, नेक्स्ट मंडे तक सबमिट करना है. सो प्लीज टॉक टू मी accordingly. I can guide or discuss. Okay, okay. Devang, Prithviraj, thank you. Vishwajit, Chanel, Arshiraj, Prithviraj, आप लोग बोलते जाओ, मुझे बताते जाओ. Then second question. Second question, I think been discussed by Divya ma'am. Eigenvalue K properties. Second question, eigenvalue K properties. Okay. ऐसे क्वेश्चन या यही क्वेश्चन डिस्कस किए होंगे. ओके विश्वजीत. स्टूडेंट्स मुझे बता देना जो भी क्वेश्चन में डाउट है. प्लीज लेट मी नो द क्वेश्चन इन विच यू हैव अ डाउट, प्लीज. Then third, fourth, Cayley Hamilton, which we had discussed in a previous lab session. Already discussed in previous lab session. Okay. 3 and 4. Fifth is not discussed, I think, by any of the faculty. Fifth या उसके बाद के क्वेश्चन शायद डिस्कस ना हुए हो. प्लीज लेट मी नो. विश्वजीत, पृथ्वीराज, मीत. फाइव सिक्स सेवन का बता दो. देवांग, वो मैडम आपको बताएंगी. मैट्रिक्स एल्जीब्रा 1, मैट्रिक्स एल्जीब्रा 2. ठीक है, वो आपको मैडम बताएंगी. ओके जनिल. मैं मैडम से बात करूंगा कि भाई आप मिड 1 का सिलेबस अनाउंस कर दो. सो शी विल अनाउंस. ओके विश्वजीत. ओके ओके. So students, In a next lab session, first of all, we will see 5, 6, 7. Next lab session में हम 5, 6, 7 देखेंगे. आपको नहीं करना है, but you all will submit question 1, 2, 3, 4 on or before next Monday. आप सब लोग question 1, 2, 3, 4 सबमिट करेंगे नेक्स्ट मंडे से पहले. ओके, उसका लिंक मैं जनरेट कर दूंगा. So is it clear to all of you? 1, 2, 3, 4 question. 5, 6, 7 हम नेक्स्ट लैब में देखेंगे. Yes, there you will be asked such questions only which can be solved within 1 minute. अभी मैंने जो सॉल्व किया ऐसे क्वेश्चन 3-4 मार्क के होते हैं, ऐसे नहीं होंगे. हाँ, 1 मार्क के ही क्वेश्चन होंगे जो आप सॉल्व कर पाए. There will be a question of 1 minute only which you can be able to solve. Yes, pattern will be same. Yes, it has MCQs, so 1 mark, 1 mark, 1 mark, 1 mark. All questions will be of 1 mark. तो नेक्स्ट मंडे तक आपको ये असाइनमेंट, सेकेंड असाइनमेंट के क्वेश्चन 1, 2, 3, 4 करने हैं. ओके, let me know if you have any question, any question regarding anything, please ask. Okay, so now one by one let me take your attendance. Mechanical students, auto students, civil students, okay, chemical students, national, international, both. Okay, so that's it. Do take very good care of yourself. आपका ध्यान रखिए, फैमिली का ध्यान रखिए, बाहर मत ही निकलिए. Do take very good care of yourself. कुछ दिन संभाल लेना है, that is it. Thank you very much everyone. Thank you so much. Thank you.